Hello, you are welcome to Maths Clinic Series. In this video, we want to look at permutation in a circle, that is cyclic permutation. And by the close of the lesson, you should be able to identify the formulas for arranging objects in a circle and in a ring. Then also solve problems in arranging objects in a circle and in a ring. Now when we talk of cyclic permutation, we are defining it as a permutation around a circular object. That is what we call cyclic permutation. This time around, we are going to arrange objects in a circle. The previous lessons that we've taken about permutation were all in arranging objects in a row or in a line. Now let's consider this. It must be noted that a circular object has no beginning and no end. We always fix one object or a person and permute the remaining. And so in general, we'll say that the number of ways of arranging n different objects in a circle is given by the formula n minus 1 factorial. Remember that in a row or in a line, if I give you a word like MA math to arrange in a row or in a line, since we have 1, 2, 3, 4, 5 different letters, it becomes 5 factorial ways. But if I'm to do the same thing in a circle, it will be 5 minus 1 factorial. And the question is, why do we subtract 1 from that if it is in a circle, but we leave it as such if it is in a row? I will explain that to you. So now, in a circular fashion, and you are asking how many ways can the 9 people be seated in a circle? If this question was to be asked in a linear fashion, like maybe in a row or in a line, we will say that in how many ways can the first person be seated on the first seat? We'll get 9 ways. Second seat, 8 ways. Third seat, 7 ways. And it continues that, and we get 9 times 8 times that up to 1. But if it is in a circle, how many ways can the first person be seated? Since we have 9 seats, we might think it's going to be 9 ways, but the answer is no, it's not going to be 9 ways. Let us assume that the first person decides to sit here. The first person sitting here, if you look at the arrangement very well, when the first person sits here, the number of people at this side, okay, let's say beside him, are 1, 2, 3, 4, and the number of people who are also here also is 1, 2, 3, 4. If the first person decides to sit here, the number on his right will be 4, number on the left will be 4. Now, sitting here, the arrangement in front of you and side by side is the same as sitting here, the same as sitting here. So there's no particular way you can sit that will be unique. Unlike the row, if you sit here, it won't be the same as sitting here. Here, whatever you sit, your position in terms of the arrangement will still remain the same. And so for how many ways can the first person be seated is going to be only one way. And after the first person has been seated, the next question to ask is in how many ways can the second person be seated? Because the first person has taken the seat, second person, whatever the position the second person will choose to sit, the arrangement in front of him, beside left and right, will be different from the first person. And so, assuming the second person decides to sit here, okay, the arrangement is not the same. Here, it won't be the same, right? For that matter, we have 8 different ways the second person can be seated. The third will be 7, will be 6, in that order. So that is how it's going to be like. Now let's take example and see how this works. In how many ways can 8 people be seated in a round table? In a round table. So these are 8 people seated in a round table. In how many ways can they be seated? The first person, assuming the first person is this, before any other person comes to sit, the first person has only one way to sit. So we can say first person is one way. Now after the first person is seated, the second person will have 7 different ways of sitting. The third will have 6 different ways, and it will go on and on until the last person is seated, and that's going to give us one person being 1 times 7, 6, 5, 4, 3, 2, 1, and everything here represents 7 factorial. All right, so 7 factorial times 1 is the same as 7 factorial, and so the answer will give us this. And that is why we are saying that if the number of people involved are 8, we just subtract 1 from 8 and we take the factorial, and so that will be the answer. So let's take note of the following informations or equations, very important. If you are dealing with cyclic permutation and the number of items involved is n, and we are selecting all of them, then we are selecting r being equal to n. For that matter, we are saying that the formula will be n minus 1, which is the same as n factorial divided by n. Right, so that is the formula. But then if we have r different objects chosen from n different objects, like we used to have it in the linear form when we say n permutation r, here too, if it is in a circle, the formula is given as n permutation n minus r factorial, then times r again. All right, so it's going to be n permutation r, then we multiply everything by r, or let's say 1 over r. No, it will be the same r because everything here represents that. So that is how it works. Now let's take permutation in a ring very quickly. Now this is almost the same as the cyclic, but then in a ring, because a ring has both sides, no matter how you position it, it's a solid figure, so it will be positioned one way at one side of it, and then when you turn it, it can also be a different arrangement. So it's like you're arranging bees. It's when you have bees wearing maybe bees that we normally wear on our hands. If you place it on a table, the arrangement from left to right is not the same when you turn it upside down. So what you mark as your first, when you turn it upside down, probably may be the last. And so in a ring, there's a slight difference in there. So here we are saying that if an object are fixed, or if objects are fixed on a ring which can be turned over, the number of ways of arranging will be n factorial over n times 2. If it is a circle, it is n over n factorial over 2, sorry, over n. But because a ring, it can be done other way around, or it can be turned over, so that becomes times 2. So in the nutshell, the formula then becomes n minus 1 all factorial divided by 2. Again, if we are selecting r object choosing from n different objects, then the formula again comes as n factorial n minus 1 factorial times r. Then we multiply again by 2 because it can be turned other way around. Let's take 2 examples to end this part of the video. Then we'll do maybe the B part of this same topic and solve more examples that follows. So let's take example number 1. The representatives of 5 countries attend a conference. In how many ways can they be seated at a round table? And I'm sure your answer is right, as n minus 1. So if there are 5 in all, there's going to be 5 minus 1, which will be 4 factorial, and the answer is 24 ways. Then there are 9 keys on a standard ring with no clasps. How many different arrangements are there? 9 keys. Good. I'm sure once again it will be 9 minus 1 factorial divided by 2 because this is a ring. All right. Our next question is a bit detailed, so we'll leave that for the next video. So call it part B, or the B part of this. So with this, we come to the end of this lesson. Thanks so much for watching.